What's going on? My name is Rick, and in this video, I'm going to be showing you how you can read native code from JavaScript. Let's go ahead and get into it. Alright, so if you're going to do this, you're more than likely you are a pro at this point. Again, I covered a lot of the fundamentals in the programming fundamentals, and that's the whole reason why I got into this trying to understand native code in JavaScript. And when I mean native code, I mean code that the runtime provides for you that's already there for you to be able to use. So in the programming fundamentals, we talked about a lot of the different math operations that you can use, and we talked a lot about the functionality that's already pre-built into the language that you can actually use as well. But again, we don't want to just use what's already there. We want to learn and understand our ability to be able to come up with solutions for problems. So over there, I talked a lot about different possibilities and how to actually come up with a solution, how to actually answer one of those problems, how to actually come up with a genuine solution. And I talked a lot about that over in programming fundamentals. But over there, I talked about a specific function called the absolute function. And in the absolute function, I just went ahead and implemented a small absolute function where I times any given number by a -1, which by definition, -1 is an identity number. So you always get back what you multiply it by. So if you put in -2, you will get +2. -2 times -1 will give you a positive number. Negative times a negative is always positive. So that's the way I implemented it. But I got a little curious. I'm like, how is the runtime actually implementing this, right? And I went ahead and wrote a blog post, which is also linked below this video, so you can go ahead and check that out. But whichever case may be, you can go check out the blog post and read about it there. But I'm just going to go over to the blog post here. As you can see here, how to read native JavaScript code. And here's the little function that I implemented. So it's called absolute function. I'm going to drop back into terminal. We're going to look at this, and then I'm just going to abs.js. I'm going to paste this in here, and this is my implementation that I cover in the program fundamentals. If you haven't seen that video, go over to JS Academy and check that out. But as you can see here, I went ahead and let's just do a console.log. Actually, let's just save this. Let's do node here. And if you do something like console.log, and then you do math.abs, you get back a function. As you can see, this function, we want to actually see what's inside that function, right? So if you do abs.toString, this should give you back the code that's actually in there. Well, it doesn't give you back anything. It just gives you function abs native code, which is kind of useless, right? We actually want to see the implementation of the absolute value, right? So if you come back over here, you can see here it gives you back the native code, and you can actually use this tool that Google provides for you. It's called the code search. So if you click on this link, this will take you over to Google, and then you'll be able to use the functionality called code search for Chromium. So if you type in here math, you will get a bunch of different possibilities of what you're looking for. And the very first one here is src.va src.js math.js. If you click on here, it will go ahead and actually show you the implementations of the functions. As you can see, the very first one is the absolute function. Copy this, and the math absolute, we pass in x, and then we check if x is positive, then we return back x if it's positive. Otherwise, we go ahead and do a subtraction with the x value. So let's go ahead and pull this into our little text editor here, and I'm going to do vim abs, and as you can see here, that's a function that I implemented over there. And then what I'm going to do is I'm going to save this. And those are pretty much the two functions here. And let's go ahead and just read them one at a time here. And as you can see, this is the one that I implemented up here, which is if number is greater than 0, return number. Otherwise, -1 times number will go ahead and give you the absolute value. And as you can see here, Google is implementing it a little bit different. We pass in the value x, then we do make sure this is an actual positive number. Then we go ahead and check, is x greater than 0? If it is, we return x. If it's not, we go ahead and pass in the negative number, and we go ahead and subtract negative and a negative, which gives you a positive, that in turn gives you a absolute value. So for example, if you pass in -2, -2 of -2 will give you 2, right? And that goes ahead and gives you back the value with the absolute function. As you can see here, it's really similar to mine. I mean, the only thing that they're doing differently than what I'm doing is they're doing a subtraction. And the reason probably why they're doing this is more than likely that there's some sort of a small performance improvement over the multiplication. But comment below, tell me what you think. Do you think this is is my code any faster than theirs? I know the branch does give me a little overhead as far as performance. That's why they're using the ternary operator. And obviously, if I had to do the optimization, obviously I'll go with the ternary operator as well. I also covered the programming fundamentals, but that's beyond the point. What I'm trying to get here is this multiplication right here, -1 times the number, is that any faster than 0 minus the number? Again, think about that and comment down below. Let me know your thoughts on that. But pretty much that's how you would go ahead and look at the native code. Go over to code.google.com. Again, the link is below this video. You can go over just to the blog, and then that links you to code search. And that goes ahead and lets you actually go ahead and look through that source code there. But again, I just wanted to make this little small video here and show you how you can actually dig into the native code that Chromium Max is actually using. Again, this is just a small sample. You can go through here and actually see how a lot of the functionality behind the scenes is actually working. This is really important if you want to go ahead and build your own library, if you understand the inner workings of a library. Great example for you to be able to actually go through here and actually see how they're actually calculating some of this. So here's sine, here is cosine, here's the tangent, hypotenuse, square root, cube root. You can go through here and actually look through some of this source code if you are so inclined to. So that's all I got for this video. Make sure you give it a thumbs up. Make sure if you haven't gone through the program fundamentals, you go over to chaseacademy.com and check that out. And I'll go ahead and catch you on the next one.